The Virgo Supercluster or the Local Supercluster is a mass concentration of galaxies that contains the Virgo Cluster in addition to the local group, which in turn contains the Milky Way and Andromeda galaxies. At least 100 galaxy groups and clusters are located within its diameter of 33 megaparsecs. It is one of millions of superclusters in the observable universe. A 2014 study indicates that the Virgo Supercluster is only a lobe of a greater supercluster, Laniakea, which is centered on the Great Attractor. Background: beginning with the first large sample of nebulae published by William and John Herschel in 1863, it was known that there is a marked excess of nebular fields in the constellation Virgo. In the 1950s, French Euro-American astronomer copyright Radon de Vaucouleurs was the first to argue that this excess represented a large-scale galaxy-like structure, coining the term local supergalaxy in 1953, which he changed to local supercluster in 1958. Debate went on during the 1960s and 1970s as to whether the local supercluster was actually a structure or a chance alignment of galaxies. The issue was resolved with the large redshift surveys of the late 1970s and early 1980s, which convincingly showed the flattened concentration of galaxies along the supergalactic plane. Structure: in a comprehensive 1982 paper, Brent Tully presented the conclusions of his research concerning the basic structure of the LS. It consists of two components: an appreciably flattened disk containing two-thirds of the supercluster's luminous galaxies, and a roughly spherical halo containing the remaining one-third. The disk itself is a thin ellipsoid with a long axis/short axis ratio of at least 6:1, and possibly as high as 9:1. Data released in June 2003 from the 5-year 2-degree field galaxy redshift survey has allowed astronomers to compare the LS to other superclusters. The LS represents a typical poor supercluster of rather small size. It has one rich galaxy cluster in the center, surrounded by filaments of galaxies in poor groups. The local group is located on the outskirts of the LS in a small filament extending from the Fornax cluster to the Virgo cluster. The Virgo supercluster's volume is very approximately 7,000 times that of the local group or 100 billion times that of the Milky Way. See volumes of similar orders of magnitude. Galaxy distribution: the number density of galaxies in the LS falls off with the square of the distance from its center near the Virgo cluster, suggesting that this cluster is not randomly located. Overall, the vast majority of the luminous galaxies are concentrated in a small number of clouds. 98% can be found in the following 11 clouds: Canes Venatici, Virgo Cluster, Virgo 2, Leo 2, Virgo 3, Crater, Leo I, Leo Minor, Draco, Antlia and NGC 5643. Of the luminous galaxies located in the disk, one-third are in the Virgo cluster, while the remainder are found in the Canes Venatici cloud and Virgo 2 cloud, plus the somewhat insignificant NGC 5643 group. The luminous galaxies in the halo are also concentrated in a small number of clouds. This distribution indicates that most of the volume of the supergalactic plane is a great void. A helpful analogy that matches the observed distribution is that of soap bubbles. Flattish clusters and superclusters are found at the intersection of bubbles, which are large, roughly spherical voids in space. Long filamentary structures seem to predominate. An example of this is the Hydra Centaurus supercluster, the nearest supercluster to the LS, which starts at a distance of roughly 30 mpc and extends to 60 mpc. Cosmology large-scale dynamics since the late 1980s it has been apparent that not only the local group, but all matter out to a distance of at least 50 mpc is experiencing a bulk flow on the order of 600 km per second in the direction of the Norma cluster. Lyndon Bell et al. Dubbed the cause of this the Great Attractor. While astronomers are confident of the velocity of the LS, which has been measured against the cosmic microwave background, the nature of what is causing it remains poorly understood. Dark matter the LS has a total mass ma per mil 1015 ma per mil and a total optical luminosity La per mil 3a, 1012 La per mil. This yields a mass-to-light ratio of about 300 times that of the solar ratio. a figure that is consistent with results obtained for other superclusters. By comparison, the mass-to-light ratio for the Milky Way is 63.8, assuming a solar absolute magnitude of 4.83, a Milky Way absolute magnitude of 20.9, and a Milky Way mass of 1.25 a, 1012 ma per mil. These ratios are one of the main arguments in favor of the presence of large amounts of dark matter in the universe. If dark matter did not exist, we would expect much smaller mass-to-light ratios. Maps. Diagrams. See also: Able Catalog, Large-Scale Structure of the Universe, List of able clusters, Supercluster. References. Tully, Brent. The Local Supercluster. Astrophys J 257, 389 a €422. Bibcode, 1982 APJ. 257 389 T doi, 10.1086/159999. Monquito, Oscar. Superclusters and Other Stuff. Colton 12, 124 a €118. Lyndon Bell, DAL Spectroscopy and Photometry of Elliptical Galaxies. VA Galaxy Streaming Toward the New Supergalactic Center. Astrophysical Journal 326, 19 a €49. Bibcode, 1988 APJ. 326. 19 LDOI, 10.1086/166066. CS1 Maintenance, Explicit Use of AL. External links: The Atlas of the Universe, a website created by astrophysicist Richard Powell that shows maps of our local universe on a number of different scales.